So think back now what we've got to actually do, because in part A it says find the time taken for the box to come to rest. Okay, they're not asking us actually to solve the differential equation. Okay, so even though I'm going about that process here, okay, and I've got to this stage now, I don't need to get it so that I got v as a function of t. Okay, so I don't need to rearrange this to solve the differential equation to get v equals. All I've got to do is simply answer that question. Find the time taken for the box to come to rest. So I pretty much got my t equals here. Yeah, I can do a little bit of tidying up here, but I pretty much got the t here in terms of v, and I can then work out what the time, how long it takes, the value of t for it to come to rest. So perhaps what I'll do here, just to tidy this up a little bit, because that's minus t, I'll change the signs, yeah? So I'll make that positive, but I've got to then change all the other signs, so this will become negative, and this will become positive. So let's write that one first, because this becomes positive, so I'll have 1/3 ln 1.6, and then this becomes negative, take away 1/3 ln 0.4 plus 0.6v. Okay, now you're taking them away, all right? So that means then, and there's a third in front of both of them, yeah? So what I can do, I can factorize that third, okay, and do ln 1.6 take away ln 0.4 plus 0.6v. And we've got to think back then to the rules of logarithms, okay? When you're taking away, you can write that as a single logarithm, yeah? When you're taking away logarithms, you can write it as a single logarithm where you are dividing. So 1.6 divide by 0.4 plus 0.6v. Okay, and then we can answer the question. So quite simply it says, what's the time it takes for the box to come to rest? So of course we know when the box comes to rest, well, v is equal to 0, yeah? So you just plug 0 in there, so t will equal to 1/3 ln 1.6 over, well that of course then, well that's 0, so this would just be 0.4. So on your calculator, you can type in 1/3 ln, and 1.6 divided by 0.4 is actually 4, isn't it? And I get 0.462 seconds. Okay, so not very long. Put 3 decimal places there, that kind of makes sense with our solution here. Okay, so in B then, it says give the possible physical interpretation of the resisting force. So when they say physical, okay, they're asking, you know, where do these values arise from? Okay, well, what's causing these values? And what I do here is think about them as separate entities. Okay, appreciate here that 0.4 is a constant; it doesn't change. Okay, but this part of the resistance here will change. Okay, because it depends on V, doesn't it? So if you think about it, the higher V is, then the greater this part of the force is going to be. Okay, which means the greater that V is, the greater the speed is, the greater the overall resistance is going to be. So think about sort of what physical effect, okay, or what physical cause can affect this resistance getting bigger as the speed increases. Okay, and conversely then, as if you think about it, as it slows down, and in this case this is slowing down, okay, V will get smaller, which means this overall value will get smaller as it slows down, so the actual resisting force is getting smaller as it slows down. Okay, so what sort of physical cause will make resistance to get smaller? And if you think about it, you know, if you're going out and you run against the wind or whatever, when it's very windy, it's harder, isn't it, when you're running, because of that air resistance, yeah? And if you slow down, it's not so difficult. Okay, so the effect of air resistance is not so bad as you slow down. Okay, And that's what's going on here, I'd say, okay, with regards to this here. This here, this 0.6V, okay, probably refers to the air resistance, okay? So 0.6V is likely due to the air resistance, okay? Because it will increase, yeah? If you think about it, it will increase. It will increase as the speed increases. And conversely, it will decrease. The value will decrease as the speed falls, which is consistent with experience, isn't it? Think about when you go out for a run on a windy day, it's harder, isn't it? There's more air resistance as you go faster. Okay, now let's think about the 0.4 part. Okay, now that's constant. Now think about the other resistance you could have. Okay, the other resistance you have, of course, is friction. Yeah, the friction, the contact between the you know, if it was a car, the contact between the tires and the road surface. Okay, that will be constant. That's not affected by speed. Okay, once you move in, that friction is going to be the same. So I'd say here is likely due to friction. Okay, between, in this case, the box and the floor, yeah, the box and the surface. Okay.